MCV4U1 Lesson 3. In this lesson, we are going to talk about the meaning of end behavior of a function and the asymptote. Let's have a quick review on what we've done. We informally define the meaning of limits, and we calculated some simple limit such as limit of 3x plus 5 as x approaches 2 in different ways. One way was using the table of values, one way was the concept of limit, and the other way was using some properties of the limits. Let's find this limit in two ways. The first way is the concept of limit. As x getting close to 2, 3x is getting close to 6. And 3x plus 5 is getting close to 11. Therefore, limit of 3x plus 5 as x approaches 2 is 11. We find the same limit using the properties of the limit. Limit of 3x plus 5 as x approaches 2 is the limit of 3x as x approaches 2 plus limit of 5 as x approaches 2. Limit of addition of two functions is addition of limits. Limit of a constant times a function is the constant times limit of the function. Therefore, limit of 3x as x approaches 2 is 3, limit of x as x approaches 2, plus limit of 5 as x approaches 2. We know limit of x as x approaches a is a, and limit of a constant as x approaches a is the same constant, two properties of the limits. Therefore, our limit would be 3 times 2. Limit of x as x approaches 2 is 2, and limit of 5 as x approaches 2 is 5. This limit would be 6 plus 5, that is 11. Let's have another example. Limit of x2 minus 4 over x minus 2 as x approaches 2. You can use a calculator and find the value of the function at x equals 1.99 or x equals 1.999. And by doing that, you see the value of the limit is very close to 4. Let's find this limit using some algebraic manipulation. As you know, the properties of limit cannot be used in this question because it is a fraction and the denominator as x approaches 2 is approaching 0. To find this limit, we factor the numerator of the fraction. x2 minus 4 is x minus 2 times x plus 2, and our limit can be written as limit of x minus 2 times x plus 2 over x minus 2. Since x approaches 2, x minus 2 is not 0. X is not 2, therefore x minus 2 is not 0. We divide both the numerator and the denominator of fraction by x minus 2, and our limit would be limit of x plus 2 as x approaches 2. When x is getting close to 2, x plus 2 is getting close to 4. In our previous lessons, we talked about one important theorem. The limit of f of x as x approaches a exists if and only if both the right side and the left side limit of f of x as x approaches a exist and they are equal. And we came to conclusion that when you want to find the limit, in many cases the best candidate is the number itself. For example, when you want to find the limit of 3x plus 5 as x approaches 2, you can substitute x by 2 and find the limit. This is called substitution methods. Unfortunately, this method is not working in many cases, like this example. You're not allowed to plug in 2. If you plug x equals 2 into this function, you get 0 over 0, which is indeterminate form, and we are going to talk about that in our next lessons. Limit of f of x equals infinity as x approaches a. If we can make f of x arbitrarily large and positive for all x sufficiently close to a from both sides. In other words, when x is getting close to a, f of x is getting bigger and bigger on positive direction of the y-axis. Similarly, we define limit of f of x as x approaches a equals to negative infinity. In this case, we can make f of x arbitrarily large and negative for x sufficiently close to a from both sides. When x is around a from the right side and f of x is arbitrarily large, we say limit of f of x as x approaches a from right side is infinity, and when it is from the left side, limit of f of x as x approaches a from the left side is negative infinity. Let's look at this example. At x equals 1, the function is undefined. When x approaches 1 from the right side, limit of f of x is positive infinity, as you see. As x approaches 1 from the left side, limit of f of x is negative infinity. In this case, we say x equals a is the vertical asymptote of the function. In other words, x equals a is the vertical asymptote of f of x when limit of f of x as x approaches a is either positive or negative infinity, or one of the right side or left side is either positive or negative infinity. This doesn't mean the limit is positive, negative infinity. It's either positive or negative infinity. For example, if we consider f of x equals x minus 1 over x minus 3, x equals 3 is the vertical asymptote of the function. When x approaches 3 from the right side, y approaches positive infinity. At x equals 3, the limit is infinity, a little bit more than 3, both numerator and the denominator are positive, and the limit is positive infinity. And when x approaches 3 from the left side, the limit is negative infinity. A little bit less than 3, let's say 2.9. The numerator is positive, the denominator is negative, the fraction is negative. Therefore, the limit is negative. X equals 3 is the vertical asymptote of the function. Limit of f of x as x approaches infinity is L when f of x is getting close to L for arbitrarily large positive for all x. Limit of f of x as x approaches infinity in this question is positive 5, and limit of f of x as x approaches negative infinity is negative 5. Let's calculate a couple of limits. Limit of x2 plus 3x as x approaches negative infinity. If you look at the graph of this function, it's a parabola, and the direction of opening is upward. When x approaches negative infinity, f of x approaches positive infinity. Limit of 2x minus 1 over x plus 1 as x approaches infinity. If we divide both the numerator and the denominator by x, this limit can be written as 2 minus 1 over x divided by 1 plus 1 over x as x approaches infinity. Limit of 1 over x as x approaches infinity is 0. When x approaches infinity, 1 over x approaches 0. Therefore, our limit would be 2 over 1, which is 2. Limit of 2 plus 1 over x plus 3 over x2 plus 5 over x3 as x approaches infinity. If x is getting bigger and bigger, all these terms are getting smaller and smaller. In other words, when x approaches infinity, 1 over x, 3 over x2, and 5 over x3 are approaching 0. Therefore, the limit would be 2. Thank you.